Hello everyone. In this video, we're going to be solving an interesting homemade functional equation. Why do I call these homemade? Because I came up with the idea, but guess what? Anyone can come up with an idea like this. Maybe you can come up with a better problem, but don't forget to share that, okay? So we have f of x plus y is equal to x divided by 1 plus xy. And we're going to solve for f. In other words, we're going to try to find an expression for f of x, which makes this a functional equation. But this is a really cool functional equation, not because I came up with the idea, but because it has two variables, x and y, which gives us more degrees of freedom. Does that make sense? We're more flexible in that sense, because you can replace x with y with x, both with 1, both with 0, maybe not, who knows? Okay, one thing that you should be careful about is not to make the denominator 0, because we have a fraction, you can't make it undefined. In other words, 1 plus xy should not be 0, which means xy should not be negative 1, or y should not be negative 1 over x. So if you want to replace y with negative 1 over x, don't do it. You can't do it. Too bad. Okay, let's see how we can solve this problem under these conditions, right? Well, when you get a functional equation, there are kind of mainly two types. One with a single variable like f of x, and those are usually easy to solve most of the time, because if they gave you, suppose, something like this, right? And let's say they told you that this is equal to x, this is super easy, because all you have to do is set it equal to t, solve for x, plug it in, and boom, you're done. Super easy. Now, this one is different because you have two variables, but guess what? That doesn't mean y and x have to be all the time different. They can be equal. For example, you can set y equal to x, or just replace y with x and leave the x alone. I can also write y equals x, but sometimes it's better not to write equal sign, because we're not necessarily saying, because you could say something like replace y with x and x with y. Does that mean y equals x and x equals y? Well, maybe. Who knows? So if you replace y with x, you get f of x plus x equals x over 1 plus x squared. Does that help at all? I don't know. We don't know what f of x is. I mean, we can guess and check. Like we can say, okay, suppose f is a linear function. That's one of the function types, right? So we can say, okay, suppose f of x can be written as ax plus b, plug it in, plug it in, plug it in, and then see if you can get something meaningful, which you're not going to get anything from here. Because first of all, look at the expression on the right-hand side. Linear, 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 and all of a sudden you get something rational. That's impossible. So this is not going to work with linear functions. So we have to try something else, or do we have to try all the function types? I mean, yes, this might work if you kind of cover all the function types. Is it exponential, logarithmic, trigonometric, so on and so forth. But there's so many different types. It's kind of like very brute forcey. So we kind of need to act smarter here. So for that reason, why don't we just do something else? Maybe something like replace y with 0. Can we not do that? Sure, let's do it. If you replace y with 0, you're going to get something like this. f of 0 plus y, right? Oops, I meant to replace y with 0, not x with 0. Sorry about that. If you replace y with 0, you get f of x plus 0 equals x over 1 plus 0, which is 1, which is x. Uh-oh. And 0 is not going to add anything, so it's f of x equals x, which is very interesting, don't you think? So it's kind of like f is a function whose inverse equals itself. In other words, if you compose f with f, you get the identity function. What is that supposed to mean? Does that mean f of x equals x? Well, f of x equals x is one of the solutions to this functional equation, but this is not necessarily the original functional equation that we have, because ours is more complicated. But this just came up as a result, right? But this could be a good clue. We can explore different functions and test them with the original. F of x equals x obviously is not going to work, because this is going to give you x. F of x plus y is going to be x plus y, but this is not the same as x plus y. Houston, we have a problem. But guess what? We have a solution too. So linear didn't work. And replacing y with 0 did not work. What else should you try? You can replace x with 0, of course. You should always try the zeros first, because 0 is awesome. 0 is an annihilator. It just makes things disappear. Great, let's do that. f of 0 plus y equals 0 divided by We don't care what it is, right? It's just 1. But it's 0 at the end. But you have to be careful. You don't want to do 0 over 0. No, it's not 1. It's not undefined either. It's indeterminate. I know some people don't like the term indeterminate. There is no such thing. Guess what? There is such a thing called indeterminate forms, like 0 over 0, 1 to the power infinity, 0 times infinity, so on and so forth. So get used to it. But anyways, that's a different story. Sorry, I kind of have strong feelings about that. So what do we know now? We know that f of something is 0. Now, if f of 0 is a constant like c, we get f of y plus c equals 0. This is interesting. Why? Because how can f of something be 0? Here's the issue here. Are we sure we can replace x with 0? No. The domain wasn't given on purpose because that would probably give you a clue, and I didn't want to give it away. Sorry for the hidden domain, but you can try. Let me just tell you this at this point, okay? The domain is not the set of real numbers. Can I just say that? I hope I'm not giving away too much. But notice, x equals 0 didn't really give us anything, but something kind of meaningless because you don't want f of a variable to be 0. Because that could mean f of anything is 0. Is that possible at all? No, because if that was the case, then the whole thing should be 0, which means x equals 0, but x can be anything else, right? So it's not true. We kind of get a contradiction. This is not going to fly, or it's not going to work, in other words, okay? So what should we do? We should try another option. We exhausted the zeros, but one thing we didn't use is maybe we should use some. Oh, by the way, I know how to solve this problem, but I'm kind of going through some loops because you know what? This should be the thinking process for you. Like if I know the solution and show you right away, where's the learning? I mean, the point, that's not the point. Some people say like, oh, I can do this in 30 seconds. Great, do it then. But my channel is focused on, sharing with people different teaching methods, okay? Or different solving strategies, whatever. So I can also replace, maybe, if I can turn this whole thing into x, wouldn't that be amazing? Yes, but how can you do that? Well, here's what I want. I want f of x plus y to be x, which is possible because of the two variables. You know what that means? It means replacing y with x minus f of x, which is valid. You know why? Because for an particular x value, f of x is defined if x is in the domain. Of course, we can only use x values that are in the domain. So both of these are well defined. Their difference is well defined, right? Hopefully. So that gives us a y value. Great. Now we can go ahead and replace y with this in the original problem. Let's go back. So this kind of showed you what you need. And now I'm going to go ahead and plug it in. You're going to see the process one more time, okay? Now, replace y with x minus f of x. Y with x minus f of x. And you got to do it on both sides. Replace y with x minus f of x. Beautiful. Well, not beautiful, but it's not bad, okay, for now. F of x cancels out. The most beautiful part is this gives you f of x. On the right-hand side, though, things aren't that nice. This gives you 1 plus x squared minus x f of x. Great. Now, if we can extract f of x from here, which we can, by the way, then we'll be super happy, don't you think? All you have to do is distribute and isolate f of x. That's all you have to do. Simple, right? So if you distribute, like cross multiply, 1 plus x squared times f of x minus x times f of x squared. Uh-oh, Houston, we have a problem. That'll be a quadratic equation. Quadratic in f of x, which is kind of interesting. By the way, this solution method was not planned, so I'm going to call this first method. And then I'm going to proceed with the second method. Okay? So my first method is replace y with x minus f of x because that gives us f of x. But too bad, it's a quadratic equation. But guess what? We can solve this, right? Can't we? Hopefully there's a solution. Now to solve it, we're going to use the quadratic formula. Treat x as a constant and f of x as your variable. I know it's kind of weird, but call this like a y or t, then you'll get an equation in whatever variable. So from here, if you want to call this y, that's fine. It'll look like this, and I think this will look more quadratic than the first one, right? And now we're going to solve for y. That's our goal, okay? Because y is equal to f of x. So to solve for y, we're going to use the quadratic formula, negative b, plus minus the square root of b squared. Uh-oh. that's going to give us a quartic, minus 4ac, which is 4x squared. Beautiful. This should give us something meaningful, right? Hopefully. From here, we get 1 plus x squared plus minus. Inside, let's find out what it is. 1 plus x to the fourth minus 2x squared minus 4x squared. Uh-oh, that didn't work well. B squared minus 4ac. You know what? I'm probably missing something because this is supposed to give me something nicer than this. But anyway, let's proceed. This gives me x to the fourth minus 6x squared plus 1. I mean, to be honest with you, I was expecting something like a perfect square under the radical. So I can just directly simplify this. Negative b plus minus squared. B squared, I'm checking my work, minus 4ac, which did not work. And you can see that we get stuck here, right? I don't know why. We probably made a mistake somewhere here when we did the replacements. 1 plus xy, y is replaced with x minus f of x. This looks good to me. F of x equals this, x divided by 1 plus x squared minus x f of x. And then we distribute. It looks good to me. I don't know. I can't tell. I have no idea. So you can hopefully tell me why I got stuck, because I'm about to go into the second method. Anyways, you see the process, problem-solving process. Sometimes you get stuck. Okay, let me rewrite the original problem, f of x plus y. And it's also super funny when you get stuck on a problem that you came up with. You know, that's even funnier. Now, here's what we're going to do. We're going to replace x with 1, okay? Why? Because that's going to give us something real nice. Let me show you. When you replace x with 1, here you get f of 1 plus y. Notice that this means you're not replacing y with anything. Leave the y alone, okay? Y is y, okay? If you want to know what it is. And x is 1, and x is 1, so it's going to be 1 plus y. Now, let me tell you why this is really cool. F of 1 is a constant. Let's call that c, just like before. F of y plus c is equal to 1 over 1 plus y. Now, one thing to keep in mind here is if you can find what c is, it's going to be super helpful. And we can do that. How? We can actually replace y with something else. Let's think about it. Maybe I can just replace y plus c with 1. Okay, good. Now, do I know what f of 1 is? That's a good question. F of 1 is c. Yes, I know that. Great. So this is going to be helpful. Okay. So f of 1 is c. That's why we replaced it with c here. You see? You see that? Okay, great. Now, I want to set this equal to 1 because I want to get f of 1 more time. You see that? So how do you set y plus c equal to 1? You need to replace y with 1 minus c. It's kind of a little challenging task, but it can be done, right? Hopefully. So replace y with 1 minus c everywhere, and you'll get the answer. So this will give you f of 1 minus c plus c equals 1 over 1 plus 1 minus c. C's cancel out, we end up with f of 1, and this gives us 1 over 2 minus c. But f of 1 is c, so set this equal to c. Great. Distribute 2c minus c squared equals 1. Put everything on the right-hand side. C squared minus 2c plus 1 is equal to 0. Guess what? This is a perfect square, and everything is perfect. C equals 1, which means f of 1 equals 1. Which means, going back here, f of y plus 1, because c is 1, remember, c is f of 1 and it is 1. F of y plus 1 is 1 over y plus 1, which means f of y is 1 over y, which means f of x is equal to 1 over x. So the answer is the reciprocal function, which is why we ran into a problem when we got 0 for f of something, which is impossible because 0 is not in the domain, it's not in the range either. Now you get to see the domain, and this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out aplusbi, and bye-bye.